Greetings everyone. I am Udaysharma from the EEE Department of Institute of Aeronautical Engineering. Today I am going to discuss about the topic cylindrical coordinate system. Coordinate system. A coordinate system is a method for identifying the location of a point on the plane. Let us consider an point O. This can be considered as the origin. And let us consider a point P. When considered as Cartesian coordinate system or a regular coordinate system, we have two axes, x-axis and y-axis. The point P for reference can be taken as, and its coordinates can be given as x, y, as the point P is at an x distance from the point O and is at a y height from the point YO. Coming to the three-dimensional coordinate system, we have Cartesian coordinate system, such as Cartesian coordinate system as basic coordinate system, and which can be compared to the regular two-dimensional coordinate system. Then we have a cylindrical coordinate system and spherical coordinate system. The basic two-dimensional coordinate system has x-axis and y-axis for reference as Cartesian coordinate system. When going to the three-dimensional system, we have many axes, like suppose in Cartesian coordinate system, the three-dimensional form of Cartesian has three axes: the x-axis, the y-axis, and the z-axis. Z-axis, x-axis, y-axis, and z-axis. This is a three-dimensional coordinate system. Three-dimensional coordinate system. The x-axis can generally taken as length, y-axis as breadth, and z-axis as height commonly. Let us consider a point P in the given figure. Let this be a point P, as this is at a height x, at a distance of x from the point O, and at a height of z, and at another length of y. These coordinates can be given as x, y, z from origin. The cylindrical coordinates. The cylindrical coordinates in a three-dimensional coordinate system has three axes: one along the length of the cylinder, one along the radius of the cylinder, and one along the angle of the cylinder. The three coordinates rho, phi, z of a point P are defined as axial distance or radial distance. Rho is the distance from z-axis to the point P. The rho can be defined as height. Rho can be defined as height. The angle phi is the angle between this, and the projection z is defined as height, and rho is defined as the radius. Generally, the rho is radius, and phi is angle, and z is height. When compared to the Cartesian coordinate system, the z-axis coincides with the cylindrical z-axis. That is, the z-axis of Cartesian is equals to the z-axis of cylindrical. As we can see in this diagram, the cylindrical coordinate system, how it can change the radius, the height can be varied, the radius can be varied, the angle also varies as rotation happens. Conversion of coordinates. For the conversion of cylindrical coordinates and Cartesian coordinates, it is convention to assume that the reference plane is a former of the Cartesian xy plane with z as 0 for the general equation, and the cylindrical axis is the Cartesian z-axis. Then the z-coordinate is same in the both systems. The correspondence between the cylindrical and Cartesian xyz axis are same as polar coordinates. As discussed earlier, the z-axis of the cylindrical coordinate system coincides with the z-axis of the Cartesian form. So the z can easily be converted as z-axis of Cartesian to cylindrical. Let us say the y and x. The x-axis is rho times the cos phi. As we can see, the form is cos phi times the angle phi is can be defined here. The x is cos phi times the rho as the rho. And similarly, y can be defined as rho sine phi. Or to simply say, when we consider the angle cos phi here, it is x by rho. And similarly, we get this equation sine phi is equals to y by rho. We get this equation. This as the coordinate is set. We have three conversions from Cartesian form to the coordinate form. If we want to convert the Cartesian, if you want to convert the cylindrical to Cartesian, that is the above equation. If you want to convert the Cartesian to the cylindrical, then we can do this. From the above equations, we can write phi is equals to x, and we get sine phi by rho cos phi, and we get y by x is equals to tan phi, and the phi is equals to tan inverse of y by x. We also know that z equals to z, and for the that for x square is equals to x square plus y square gives rho square cos square phi plus rho square sine square phi, and we get rho square is equals to x square plus y square, and rho is equals to root of x square plus y square. So if we want to convert the Cartesian to cylindrical form, we get these three equations. The range of, and similarly, one important thing to know is that the range of rho, phi, and z, the range of height of a cylindrical, of a radius, the range of radius of a cylinder can be of 0 to infinity, that is 0, infinity. The angle generally lies from 0 to 360 degrees, that is 2 pi. The height can be in the positive direction or in the negative direction. So it can be from minus infinity to plus infinity. Applications. Cylindrical coordinates are useful in connection with objects and phenomena that have some rotational symmetry about the longitudinal axis, such as water flow in a straight pipe with round cross section, heat distribution in a metal cylinder, electromagnetic fields produced by an electric current in a long straight wire, accidental acceleration disks in astronomy. Suppose this is a long current carrying conductor straight wire. The EMF generated here can be calculated through the cylindrical coordinate system. Thank you. This is Udaysharma signing off.